Okay, good afternoon class. You guys had some homework? The homework was exercise 9 on page 23, number 6 and 7. 5, 6 and 7. Okay, any problems there? 6. And this is on page 24. Okay. Here's example 2, I'll use that later. Alright, so we told in exercise 9 on page 24, number 6, a circle with diameter before 6,116 centimeters is placed inside a rectangle. So we touch the sides of the rectangle in 3 places. So a circle with diameter before is placed inside the rectangle. Okay. So basically what you should understand that to be is, whoops. What you should understand that to be is that the diameter of the circle is 6,116. That's all. So that means to say that the length or the breadth of this rectangle is 6,116 centimeters. You see that? Which means to say that the radius is half of that. So you say 6,116 divided by 2, 3,058. So there you have a radius, you have 3,058. And why do I work out the radius? Because when we were doing circumference of a circle, 2 pi r. When you're doing the area of a circle, pi r square. Not so? So, that is the reason why I worked out the radius. Then we are told inside the rectangle, so it touches the sides of the rectangle in 3 places. More circles are placed inside the rectangle. Each circle touches the circle to its left in 1 place, which means to say it's this point there. And has its center on the line of AB, which means to say it's in line with the center. So all the centers here lies in line there. You all understand? You all okay with this, no? With A and B, the midpoints of the side, so A and B is the midpoints of the sides of the rectangle on which they lie. Which means to say now, that is going to be 3056, 3056. Okay, but it doesn't look like that is needed because we already indicated. Sorry?
The textbook it says 16 centimeters, not 6,116.
Sure.
Yes.
So where's that 6 coming from? Just read in your book why there's a word there. No. So is this a typo on my side? Okay, no problem. So you all agree 116. 16. Okay? I was wondering, the number is fairly large, but okay. But you all see what I'm seeing, eh? Okay, I'm not going crazy yet. So if that is 16, then measuring there to there is 16. Not so? You all agree with that? So if that is 16, then this has to be 16. What's the radius of the circle then? 8. Okay. The radius is going to be 8. Right. Each circle touches the circle to its left in one place and has its center on the line AB, with A and B the midpoints of the sides of the rectangle on which they lie. The area of each new circle is 1/4 of the area of the circle to its left. This process is continued indefinitely. Now indefinitely, what does that remind us now of? Sum to infinity. Not so? And what's the formula to the sum to infinity? A over 1 minus 1. Okay. You will understand. So now, we got what we need. So we move on. So the question says, determine the dimensions of the smallest rectangle that will be allowed, that all the circle will fit perfectly with no gaps between them on the left and the right side of the rectangle. So determine the dimensions of the smallest rectangle. So the smallest rectangle, so to calculate the area of a rectangle, how do we do that? Area is going to be length times breadth. But my breadth is standard, my breadth has to be 16. Not so? So the only thing that is a variable here that needs to be calculated is my length. So that's already something times 16. Now to calculate the length is going to be the sum of all these lengths here. Not so? You all agree with that? So let's set up a pattern. What's the length from that point to this point? 16. Not so? So now what's the length from there to there? How do you get 8? Going back to the sum, what does the sum tell us? With regards to moving from one circle to the next, what do we know? The area of each new circle is 1/4 of the area of the previous circle to the left. Okay? So let's go again. The area of, so let's call the circle 1, circle 2, circle 3 and so on. So area of circle 1 is going to be what? How do you calculate the area of a circle? Pi r squared. So you're going to be pi, what's the radius here? 8, and 8 squared is 64, so it's 64 pi. Let's look at area of circle 2. Area of circle 2 is going to be 1/4 of this area. Not so? So you've got 1/4 of that, 1/4 of area of circle 1. It's going to be 1/4 times 64 pi. And 64 divided by pi is 16 pi. But how do you calculate the area of a circle? Pi r squared. I'm interested in what the radius of the second circle is. I divide by pi both sides. So I got r squared, the second radius is going to be 16. So your radius has to be 4. You're not going to go plus minus here? I miss.
Sorry, Mr. Bowden. Cassidy request. Is she with you?
Cassidy?
I haven't just for 1 second.
No problems. Okay, you understand? So the radius of that one is going to be 4. So the radius of the circle is then going to be 8. So you called 8 earlier on. So how did you get 8? Somebody called 8. Who called 8 earlier on? Somebody called the right answer. Was it nobody on the side? On the side? Sorry? Nobody. Okay. So that's how you get 8. If you want, you can carry on with it. You want me to show you how we get the third one? No. The area of the third one is going to be a quarter of the area of the circle 2. Not so. What's the area of circle 2? 16 pi. So it's going to be a quarter times 16 pi, which is going to be a quarter times 16 is going to be 4 pi. That's area 3. Okay? So for area 3, how do you calculate the area of a circle? It's going to be pi r squared, and this is the radius 3, or the third circle. So I divide both sides by pi. So the radius, the third radius squared is going to be 4. The square root thereof is going to be 2. So this radius, that radius, the radius of that's going to be 2. So your diameter is going to be 4. Okay, you guys got it? What was the radius of the previous one? Was it 8? Or was it 4? We doubled it. Yeah. Okay, you understand? How we get that now? Okay. So if this radius is 2, then the diameter of that is going to be 4. Why am I interested in the diameter again? Because I want to know the length of the to the and so on. So what do you notice? What did I get here now? I generated a pattern. Can you see that, people? I've generated a pattern. So the pattern, I'm taking this all the time off because of the space constraint here. Now I want to keep the diagram in focus. Okay, so I have a pattern now which is 16 plus 8 plus 4 plus and so on. So how are we going to calculate the sum of this here? Or what did that length of this could be? It's going to again be the sum to infinity. So sum to infinity is equal to a over 1 minus r. Your a value is 16 over 1 minus, and what's my r value? 8 over 16, which is half, or 4 over 8, which is half, which is going to give me 32. So that's going to give me 32 centimeters here. Okay? So we just simply say 32 times 16. So the area of this is going to be 32 times 16, which is 512. 512 centimeters or meters or what? Centimeters squared. What's the answer there? Check. Just check there for a minute before I go on to the next one. What's the answer there? Yes, 6.1. Sorry? That's right, okay. I feel better now, you see? I got the sum right for once. So they have same 512. But you understand the logic behind it. Huh? It also depends what is given to you. Then he says, determine the area of the unshaded region, corrected 2 decimal places. So if you look at the unshaded region, I'm going to go purple, is this area here. Can you see that? And so on and so on. Can you see that, people? How do you think we're going to calculate the area of the unshaded region? It will simply be the area of the rectangle minus the areas of the circles. Why am I putting infinity here? Because y is going to go on almost forever. Okay? Forever in this case. Do you guys understand? So the area of the circle minus the sum of the areas of the circles. Okay? So what is the area of the triangle and of the square? Not the square, rectangle. What's the area of the rectangle? Yes, 512 centimeters square. Minus. So what we need to do is we need to calculate the sum of the area to infinity of the circles. Not so? So what we're going to do is we're going to write down a new pattern for the areas of the circle. Okay? So how do you calculate again the area of a circle? Pi r squared. So area of the first circle is what? So it's basically going to be area of circle 1 plus area of circle 2 plus area of circle 3, and so that is your sequence. Not so. So the area of the first circle is going to be pi. What's the radius of the first circle? 8. 8 squared, which is 64. Area of the second circle is a quarter of this. Not so. So a quarter of 64? 16. So it's 16 pi. We've dealt with this already. A quarter of that is going to be 4 pi. And so on. Okay. So we go now with the sum to infinity. How do you calculate sum to infinity? I've written it down already. Sum to infinity is a over 1 minus r. What's my a value? 64 pi over 1 minus. How do I get my r value? It's going to be t2 over t1. So it's going to be 16 pi over 64 pi. Okay. 16 over 64 is a quarter, not so? So it's going to be 512 minus fraction 64 pi over 1 minus 16 pi over 64 pi. It's going to give you 243, comma 92 centimeters square. Is that right? I wonder how much I would give you for something else. Probably like 6 or 7 marks. Or 8 for the most. Is it worth the 8 marks? No! You say no? So imagine 16%. The sum was 16% your cycle test. Yes? Yeah, I almost thought you were going to ask a maths question. Very quick. You just had break now, didn't you? No, it's the last period of the day. I still feel like I'm in the third period of the day. Right. People, any other questions here with regards to number 6? Oh my word. Why don't we do 7 tomorrow? No? Otherwise we're never going to get through the examples. The only thing is here, where many learners make a mistake on number 7, is the bouncing story. So what they do is, I'll show you, and You can just let me know if you understood it to be like this as well. Because this is the mistake they make in number 7. Okay, the question was for number 7. We are told that the bouncer rubber ball dropped from a height will lose 25% of its height on each successive bounce. So what happens is, a quarter of its height is lost, so it retains 75% of it, or 3/4. Each successive means to say every bounce thereafter, no? Such as things one after the other. If it's dropped from a height of 30 meters, so these are 30 meters. No? This is now the ground here. So this is 30. Okay. Here's a second height bounce. Okay. So if it loses a quarter of its height, it's retaining how much of its height? 75%, or 3/4. So the height of the second bounce, just let me know where you're going wrong, no? Then I can stop. So it's 30 times 3/4. It's going to give you 22.5, no? So there's 22.5 meters. The third bounce, same story. It only retains 3/4. So it's 22.5 times 3/4. So they give you 16,875. And so on and so on and so on. Okay, that is to do with the heights of the ball bouncing. Okay, remember it's dropped from a height of 30 meters. Okay, the guy standing on top of the building, I think this building is never 30 meters. It's about double story. It's about 10 meters. Probably till the pitch of this roof is about 15 meters. There around. So 30 meters is fairly high. Okay, so don't go throwing balls from that height now. So it loses 25% of height to each successive bounce. If it's dropped from a height of 30 in the first bounce, will then have a height of 22.5, and the second bounce will have 16,875. Determine the vertical distance traveled by the ball from the time it's dropped at a height of 40 meters until it finally comes to rest. Note that the height from which the ball is dropped is 40 meters and not 30 meters. Okay. Rubber balls drop from a height and then lose 25% of its height in each successive bounce. We drop from a height of 30. The first bounce will have a height of 22.5. The second bounce will have a height of diameter to the system of the ball. Okay, so determine total distance traveled by the ball from the time it is dropped from a height of 40. So this is a different pattern here. Not so? So, in the reality, it's actually dropping from a height of 40. So, they gave us 30 to explain to us actually what is happening. So, if it's going to be dropped from a height of 40 in the first bounce, if it retains 3/4, then it's going to be 30. Not so? Again, 3/4 of 30 would give you what? 30 times 3 divided by 4 should be 22.5. Okay. So if you're looking at the total distance traveled by the bounce, okay, then what's going to happen is, here we will have 40 as the first bounce. Not so. So, it drops now and it reaches a height of 30 meters. Not so. But, what's happening to this ball? It's coming down again. Can you see that? So this is actually going to happen twice. Not so? Then the ball goes up again by how much? 22.5. And comes down by how much? To reach the ground again. Also 22.5. Then it goes up again by how much? 16,875. And comes down by 16,875. So what happens is 40 is only represented once. Can you see that? So if you're going to work out the total distance covered by this ball, I might be wrong here, no? But the total distance covered by the ball is going to be 40, which does not conform to the pattern. Okay? It doesn't conform to the pattern. Plus. So what we do is, we take this here as the sum to infinity. Why? Because they told us here, until the ball comes to rest, finally comes to rest. So the ball is going to bounce until it can't bounce any longer. Or the bounce will become negligible at the end. Okay. So it's going to be A over 1 minus R. And this is happening how many times? Twice. Can you see that? So this would simply be 40 plus your A value being 30 over 1 minus. And my R value is 22,5 divided by 30, which should be 25 is going to be 3 over 4. Just check if that's correct. Times 2. It's 40 plus 2 into 30 over 1 minus 3 over 4. 280 meters. Is that correct? 280 meters. The milker didn't even stop and finish the sum. You're supposed to tell me now I understand where I'm going wrong. Yes, my God. Watch the video again. No? But the idea what happens is the ball is dropped. You might look here now, no? Don't look that side. The ball is dropped from a certain height. This is the ground, no? It's dropped. So it's the ground. The first height on which it's dropped is 40. Okay. Then the ball goes up, but it loses a quarter of its height. So it's keeping, it retains 3/4 of its height. So 3/4 of 40 is 30. Now you see this ball is dropped from 40 meters. It's going up 30, so how much must it come down by to hit the ground again? 30. So it's going to drop, lose a quarter. So it's going to go up to 22.5 and down. So as you see, that's up and down. This here, I shouldn't have put the arrow down or up actually. The arrow is supposed to only go down here. Maybe that was the confusion. You see, dropping from there, it only goes down. Does it come up at 14 meters? No. It only goes up 30. And it comes down by how much? 30 again. Sorry? Yeah, that's why we multiply by 3 over 4. Is that what you're asking? Sorry? The 2. The 2 is because you see the ball only coming down here. What do you notice here? It goes up and down. Here, up and down. So that is up, down. This is actually down, up, down, and so on and so on. You understand? So that part here is down, down. So it's going 40 down, 30 down, 22.5 down, 16 comma down. When it went up, it only went up by 30, 22.5, 16,875 and so on. Okay. I hope this answers this question. Okay. Now I feel confident putting this question in your exam. Hi. Why not? You want a total new question that you haven't seen before. But it's the application of this what you must be able to understand. People, there must be a real life question or a practical application in your exam. Okay, they only put 1 in, and then some is normally worth like 5 marks or something. Yeah, 5, 6 marks. Okay. But you must get 1. If we don't put 1 in, remind us and tell us we're not preparing you for the final exam. Because at the end of the day, that's the main focus we have in mind, is your final exam. Okay. I'm talking so much that the day is almost over. Right, we're looking at example 2, and this is on page. Dis op bladsy 26. Nzikelo 2. No? Did I say that right? 26. People, if they say on work example 2 on page 26, evaluate the following. What does that mean? Let's calculate or determine or any of those. Okay, that's basically what it means. Evaluate the following. We got 1, 2, 5, 7, 9, 1, 7, 1, 2, 4, 5, 7, 8, 10, 11, 13, 95, 97, 98. Wat gaan hier aan? What do you notice about these numbers? I'm not going to give you now all the answers. Well, what do you notice? You notice numbers? Yes, there's numbers. It's going to 100, yes. But nobody's saying that. Nobody's saying the right stuff. But what do you notice? It's adding 1, then it's adding 2, then it's adding 1, then adding 2, and so on. Okay? Which is right? Which is right? But what else do you notice? Okay, count for me. You get 1, then 2, then 3, which is not there, then 4, then, which is not there. So what do you notice? Every third number is not there, which is also what? Multiples of 3. And what's the largest multiple of 3 that's not there? The largest multiple of 3 that's not represented there. 99. So in other words, we have a pattern looking like this. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 99, 98, 97, and so on. Then what happens is, they took out the multiples of 3. The multiples of 3 is actually removed from the sum. Can you see that? So we have the sum of how many terms is this? How many terms are here, people? What? The sum of how many terms are there? 100. Minus the sum of the multiples of 3. Not so. Can at this point, we can solve the sum to 100 terms. Okay? We can say this is simply going to be n over 2 into a plus l. Do I have my last term? Yes. Do I have n? Yes. So let's do this part of the formula first. How many terms are here? 100 over 2 into. What's my a value? Plus 100 minus. Now the sum of the multiples of 3. If you're looking at the multiples of 3, it's going to be what here? 3, 6, 9, and the last term is 99. How many terms are here? How many terms are there? Sorry? This is 1 term, 2 terms, 3 terms. So it's 3 times 1, 3 times 2, 3 times 3. So 3 times what is 99? 33. So in other words, you have 33 multiples of 3. Now say for argument's sake we didn't know that. Okay, we act like we don't know. Which we normally do, no? So we say, okay, the general term, is this an AP or a GP? How do we move from one to the next? Now adding 3, then 3 and so on. So it's Tn is equal to a plus n minus 1d. What's my a value? 3 plus n minus 1 times 3. So that's going to give you 3n minus 3 plus 3 is 0. So we set 3n, this equal to Tn. So it's going to be equal to 99. So n is going to be 33. So there's 33 multiples of 3. Can you see that? So how are we going to work out the sum of these terms? So that would be, the sum multiple of 3 is going to be 33 of those. Okay. So it's going to be a n over 2 into a plus, do I have the last term? Yes, a plus. So n is going to be 33 over 2 into a, which is 3 plus, the last term is 99. Okay. And then we just put in our calculator. 100 over 2 into 1 plus 100 minus 33 over 2 into 3 plus 99. Let's give you 3,367. 3,367. Okay. Because if you're going to look at the pattern given to us, we look at the pattern given to us. This 1, 2, 4, 5, 7, 8, that doesn't conform to a arithmetic, geometric, or quadratic. It doesn't conform to any of those. So what I do is I place numbers in its place so that it can then make either arithmetic or geometric or quadratic. Okay. Then we should do another one, you guys. I look looking very confused. Three, 3, 6, 7 is correct. Let's look at the next one. Alright. Don't forget there's no class on this Friday, ne? For those of you who attend, because of the event that's happening on Friday afternoon at school. It's some grade 8 event, okay? So for those of you who come on a Friday, there's no class on this Friday. Okay? So in example 3 on page 26, again they ask you to evaluate the following. You got 1, 2, 4, 5, 8, 10, 15, 16, 2, 5, 6, 2, 60. What do you notice here? 1, 2, 4, 5. What do you notice? What is missing? 3 is gone. 6 is gone. 7. 9. So you see what is missing here. There's too many things that's missing. Not like the previous sum. The previous sum I could have just added in. And it was clear it was multiples of 3 that is missing. What else do you notice here? The missing numbers. So you're saying 3, okay, so you're saying, so the 3 is missing, né? So 3 times 2 is 6, which is also not here. So then the next number that's not here is 7. 7 times 2 is 14, which is also not here. But how is that going to make a generated pattern for us? It's not. What else do you notice? What do you notice about the relationship between 2, 4, 8, 16? What do you notice here? Square, yes. 2 squared. 2 cubed. 2, 4. 2 to some exponent. So this could be 2 to the 0 here, not so. So 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus 2 to the 4 plus 2, 5, 6, which is 2 to what exponent? Sorry? 2 to the... So you see that is conforming to a pattern. Can you see that, people? What type of pattern? Geometric pattern. So this I can work out. Okay? This is no problem. Alright? So this is going to follow the formula Sn is equal to Arn minus 1 over R minus 1. Okay, so that one is sorted. If you look at the other pattern, what are we left with? 5. Then 10. Then 15. Then 260. Forgot to ask you, how many terms are here in this pattern? There's term 1, 2, 3, 4. So how many terms are here? If this is term 1, term 2, term 3, term 4, term 5, term... So what term would that be? No, man. If this is term 1, term 2, term 3. So what is it? 1 more. Not so? So that's going to be term 9. There will be 9 terms here, no? The next one, what do you notice here? How do I move from one term to the next? Adding 5. Then adding 5. So what type of pattern is this? Arithmetic. What's a general term here? Tn. And why do I need a general term? If I set it equal to 260, I can determine how many terms here are in the sequence. So it's A plus n minus 1 d. So that's going to give you 5 plus n minus 1 times 5. So it's going to be 5n minus 5 plus 5 is 0. So that's my general term. So that is your nth term. So it's going to be 260. What's 260 divided by 5? 50 something. 52. So there's 52 terms here. So this will follow the formula Sn is equal to n over 2 into a plus l. Can I use that formula? Yes. Why? Because I have my last term there. Okay. Let's just put here work example 3. Right. So we go S infinity, sorry, S total is going to be the sum of the powers of 2 as well as the sum of the arithmetic with a difference of 5 and the first term of 5. So going with the first one, it's going to be A, so we're going to use that first. What's my A value? What's the A value of the sequence? 1. 2 to the 0 is 1. Into R. How do I move from one term to the next? You're multiplying it by 2. What's my N value? 9 minus 1 over 2 minus 1. And we're going to add the other sequence, which is N over 2. It's 52 over 2 into A. What's the first term? 5 plus the last term, which is 260. So that's going to give us 2 to the exponent 9 minus 1 over 2 minus 1 plus 52 over 2 into A, which is 5 plus 260. Gives you 7, 4. Okay. Let's give you a hook. You can. Okay. You guys understand? Was I explain again? Oh, now it's easy to say. No, don't explain. No. So you want to go home now? Okay. I also want to go home. People, for homework. Exercise 10. Okay. Exercise 10 is on page 27. And do the odd numbers only or do the whole exercise? Whole exercise, okay. So the whole exercise, exercise 10 on page 27. Okay. People, enjoy the rest of your day. Good afternoon, class. Let's close the windows on that side, please, if you don't mind.